welcome to another episode here in the theoretical part of the texture series. And today I want to take a look to scanners, and I guess you know already how a scanner looks like, but just to give you here a sketch so we know what I am talking about. And normally we have a box like this, and there's a lid on top of that, and we have here maybe a joint, and inside of this we have a rectangular glass or acrylic plate. Inside of that scanner we have normally a line that moves back and forth, and then on top of that we put normally our object, and then we have buttons here to press to get started with this. And this area here is my interest right now, because when we have here this acrylic or glass plate, it's of course very precisely and parallel. Then we have here our object, very flat sitting on that glass normally, and underneath we have that element here, this guy, and this is a sandwich out of a light source and a sensor. And the sensor is always watching what is exactly in front of him, and the light source illuminates this. And this gives a very specific light situation, because we have always light from one side. To my knowledge, I haven't seen one with two light sources, but that might exist, of course. I do not even pretend to have a really wide overview about everything possible in flatbed scanner technology. But roughly you will see immediately after the first scan or the second which kind of light source you have, and sometimes it's really important to make some test scans so you can see how far this light, for example, works and how far the sensor can see. Because some sensors, when I have here the glass plate again and my element, some sensors can watch very deep, maybe 1 inch or more into the depths, and some have already problems after 1/8 of an inch or something like that. There's a huge variety, of course, available, and sometimes you can put objects then on top of that have this variety, and you have nearly no problem. Of course, the light will reflect here always different, but with some scanners, and most likely the cheaper ones, they have a very short focus point here, and that means you have to have something that is relatively flat. Anything else gives blurry amounts here, shallow depths of field, even with scanners. And that is pretty much all that I want to give you here from the construction. Besides that, we have of course two different measurements here that are based on the mechanics. The first one is here how the sensor is built, how much resolution I can get in this direction, and then how fine the steps are, or how small the steps are in which this whole element moves forward. And this gives finally the resolution in terms of pixels, x times y or z, whatever you like, and then you get an image. And this image is then based on, of course, pixels, and I take here only a few out. And these pixels, by the way, are not all equal in quality. The bit depth is of course very important to know how deep this whole thing can look finally into different colors. And so you have the option between 8-bit, for example, or 16-bit scanners. That's pretty much the standard or the main area. And the deeper it can look into different colors, the better you are off later, because you can reduce this all the time, but you can't improve it later on. This would be all that I have to say. There are of course several models with several features, and every scanner is different. One last thing is of course that some scanners have a light source here in the lid, and then you can have even something like film or transparent objects inside of that. You have to figure out what your model can do for you and how far it is usable for your texture work, of course. Let's have a look to some examples here. My first step normally when I start scanning is to put something on the scanner where I have some certainty with it, what it is finally. For example, the gray values here, or just all these colors. And the best way would be, of course, to create a profile from this, or just go and check these numbers here in the info palette. And that gave me, of course, directly an idea where we are in terms of neutral values. That means every value from R, G, and B should be equal. And we have here sometimes differences of 4 or 5. That is in the tolerance of the color checker. And I wouldn't go there too far. But what I see here is that the blacks are a little bit too bright and the whites are as well a little bit off. So my little first step was here to take these eyedroppers and use this here. Of course, this black here is not as black as this one, and it shouldn't be, because we need a little bit wiggle room to have here in these areas a dynamic. If we put this to black, we crash everything that is below this, and this is not 100% black, or 0% black to be more precise. And that led me finally to compare these values here with the values that I got with my color checker. It's a little paper where all these values are printed, and then I can compare them. And when I reduce then here my adjustment layer to 34 or to 40%, something like this, then I get a much better result here, and I have not to worry too much about anything else. So this was the first step, and now I feel much more comfortable with this scanner. It's not just believing or trusting in something that I haven't used maybe before. Which leads me here to the first scan, and I have used here even some other color checkers. These are a little bit cheaper than the Macbeth chart, pretty much half in price, but even similar in quality. When you take here, for example, all these gray values, it gives you immediately a nice variety, and you can create very precise curves. If you get something that was shot with this and you have certainty with one scan that that is your reference scan, then you can adjust this, and I've shown this several times. If you have any questions, please ask me in the forum, of course. And you can see here half-tone and full-tone values, if we can talk about gray and black, about tone values. But you get here already a nice texture from it. And what I can see here as well is that this scanner, it's a very cheap one, I bought it extra here for the series, has not a large depth of field here. It's very shallow, just a little wrinkle here, and it's blurry. So that was the first test here, because my other scanner are nearly 7,000 miles away at the moment, and the shipping would have been more expensive than to buy just a cheap new one. Okay, but we can see here, even with an $50 scanner, which is here exactly what we have, we can create already something when we adjust it with color charts. And yes, the two color charts here are pretty much twice in price than the whole scanner, so go figure. But anyway, we can see here we get some data, and of course we could take now here something out, make a tile-able texture, which I have done here, and then we can put this on Cinema 4D and we get something out of it. Of course, it's just flat. And I will show you that, of course, later on, how it looks like on a cylinder, for example. I use here a leather part to scan the surface, and you really can't see a thing here, I guess. And so I go now here to 100%, and you can see here a nice structure, which works certainly in a good way. But in the moment you have something here like this imprint from Lufthansa, you can see here clearly the artifacts from the one side light only. Of course, if that is a very hard object, which means it doesn't deform, then maybe you flip it one time 180 degrees and hope you get it on top of each other after adjusting, and then you could use always the darkest area, and then the light is gone, but then you have around this always shadow, or you take the average. It's not the ideal, of course, but the leather by itself has such a fine structure that I would think you get away with it. But any imprint or stronger structure needs then the attention that you have the light situation in Cinema 4D in a similar way. So this indicates, of course, something that I am aware of since pretty much 20 years. 1993, when I bought my first scanner, I put, of course, everything on it, and metal was something. And when you have chrome, for example, that turns in some scanners just black. It can't see it. It has no idea what is there. Or in some scanners it's just pure white because it's all light at all. Depends on the optical system that you have inside. Black comes only out when it's very straight chrome and the light just isn't matching it because it is built up to have more diffusion than direct reflection in it. So we have some limitations here with everything that is shiny or has a lot of reflection inside of the material from the start. But here we can see the leather maybe works fine, and we could use it maybe to produce, after all, that works maybe in the bump channel, and so we can get away with the light that we have here inside in the first place. Another example that I have shot here with my scanner is a swag bag from the Sedona Film Festival, and the beauty of that is it unveils exactly the same problem that we had before, but it's not that obvious here because it shines always light on one half of this. Here in the other direction we don't have so much to deal with this. And of course I want to show you the tile that I have created with it. It's pretty simple then to get something like this, and with some stamp work you might get a way to put the light also in this area here. It's maybe 10 minutes to do and everything is fine. And this is maybe already much more than we need, because when it's then really small, when we don't go too close to it, there is maybe nearly no repetition that we might notice. One of my tests was, of course, to see how sand is showing up here on that flatbed scanner, and I put it in a little plastic bag, and you can see here clearly the influence of the light and of course of some wrinkles. But before I scratch the acrylic glass here, because it's not a real glass plate in this scanner, I put it into a scanner, and of course I didn't want to clean up finally the mess. But the truth is I have done those things, especially for product shots. I had, I think, 12 years ago so to deal with a Pret product packaging, and so I just placed the slices of bread here on a scanner, scanned it, and I had a wonderful representation of the bread which landed on the package finally. And I could use it for the rendering for my product pre-visualization in the best way. So when I go now here to 100%, I can see here even that little wrinkle gives me here a blurry area, not that funny. And it looks a little bit faded out, not in the way I have perceived it. And we see we have no adjustment here. So let's get the curves here. And in the curves I go to load curves preset that I have shown you before. Canon little 01 is the one that I have, and as I said before, 34% was pretty much where the numbers are, right? 35 will work as well, and then we can see it's a little bit more on the side where I like to have it. This here is 1200 dpi, which is relatively high, but I think it could have some deconvolution on top of that to give a little bit more definition here of the tiny contours. But this is of course up to you how much you need. Perhaps your scanner gives even higher values, but always use the values that it is giving you by optical resolution. It's not interpolated. Interpolated is something that is artificial and introduce artifacts, of course. Always go what the scanner can give you without any calculation, just like that. Okay, so last but not least, a little test about the depths again, and I think we got already the idea how much quality this little guy has here. Even if it produces a nice sharp image here for this pattern here, which is a very fine lens close, this is not really nice here, and you can see we run into trouble even here when the fork is not even an inch away from it. This is nothing that we can fix later on in post. This is gone. This is just not usable at all. And this is maybe the simplest way to test something. Just put something in it like a fork, where you have here maybe a ½ inch of distance to the glass plate, and you can see then here on these little things exactly how far you can go away, because they move permanently away, and you can see this here very clearly. This is certainly not a scanner that I would suggest to use for 3D objects, small 3D objects of course, which is possible. And this sums it up, except for my little jump over to Cinema 4D and use 2 of my tiles that I have already introduced. Just a little test, very rough, very fast. And this material here has of course only the color enabled, nothing else, because I have no other information for this object here. And we will see later on that FilterForge, for example, can produce such textures or structures, patterns, even with bump maps and normal maps and all of that. And that gives of course much better results than this one here. But today we talk about scanners, and this is the one where we are interested in. And let's have a look to the woolen hat here for a second. And same space here in terms of cylinder, and this looks already much more promising because we have no light here captured from this very dull material, and only the edges here gives it a little bit away. Perhaps if I would have placed here a noise into the displacement, just something that comes close to the size here, I wouldn't even notice that there is a fake on work. Simulations all over the place. And of course, normally when we have an animation with a character that needs this kind of texture, the character is normally in movement, and cinematography will certainly not pull your attention to the pullover. It certainly will go to any movements or to the facial expressions. Anyway, this is not the target here to explain. We wanted to see what happens here with textures from a scanner. And as I'm pretty aware of that this was only a short little introduction, but I hope you have fun exploring the options with it, because it's pretty simple, very precise and fast. Thanks for listening. Have fun with it. Bye bye.